Sections 1.5 and 1.6 involve doing a few different operations with our real numbers, and in 1.5 we're going to start by adding and subtracting. And again, our objective if we're adding and subtracting is to find sums and differences of those real numbers. So we can add and subtract any real numbers using our number line model, or we can also add and subtract real numbers using rules involving absolute value. In our number line model in the first example, to find -8 plus 4, to use a number line to find that, I just kind of drew a number line with, don't have to have a whole bunch of numbers, I just started with -8. And if I know that I'm adding 4, to move 4 on a number line, so adding 4, I start at -8 and I just move 4 spaces to the right. And I can see after moving 4 spaces, I end up at -4 on my number line. So how do I know which direction to move on that number line? If that number added is positive, in that last example, I added 4, so I moved to the right. So number added is positive, I'm going to move to the right. If the number added was negative, I would move to the left. So for example, if that was -8 minus 4, I would be going 4 to the left instead. So the absolute value, we saw that word in our objectives, is the distance a number is from 0 on the number line. So absolute value is always non-negative, since distance is always non-negative. You can't have a negative total for a distance. So for example, the absolute value of 4 is 4. Absolute value of -4 is also 4. I can write this as the absolute value of -4 is equal to 4. So basically what that means is I have these little marks here. Think of it as kind of a 1, but it's a little bit longer and bolder. If I put that -4 inside of those absolute value symbols, basically what absolute value does, anything inside of it becomes positive. So if I start with a -4, that's positive 4. And if I put a positive 4 inside absolute value, it still ends up being a positive. So I can use absolute value when I want to find the sums of our real numbers. And again, on a number line, I could go 4 to the right. That's a distance of 4 from 0. So again, always in terms of where it is on 0. So 4 to the right or 4 to the left, -4 and +4 both have an absolute value of 4 because they're the same distance away from 0. So to add our real numbers, what I can do, if I can, let's get that practice, not quite there yet. To add numbers with the same sign, so add two numbers with the same sign, I can just add their absolute values. The sum's got to have the same sign as the addends, the two things that you're adding. So positive plus a positive, I add 3 and 4, I get 7. And also negative plus a negative, so -3 plus -4. I still add the absolute value, so I'm still looking to add 3 and 4 to get 7. This time it's going to be negative though because both of those signs are negative. So if I have different signs, a little bit different, so if I'm adding two numbers with different signs, instead of adding, I'm going to subtract their absolute values, and their sum is going to have the same sign as the addend with the greater absolute value. So you're going to think the bigger number there. If I take -3 plus 4, for example, I'm going to subtract the difference between 4 and 3. So 4 minus 3 is 1. And I know that I'm using a positive 1 because the 4 was positive and that was bigger. So if I switch that, if I do +3 plus a -4, notice this time it's still 1 because the difference between 4 and 3 is still 1. But now it's negative because the -4 is bigger. So I take that negative sign. Let's go ahead and practice those sums. Go look at some of those answers now. If I take -16 plus -8, again, same sign, so that becomes a -24. -11 plus 9, different sign, so the difference between those two is 2, and I take the bigger sign, which is negative. 9 plus -11, same idea. If I have the bigger one was negative, I look at their absolute value difference, and I make sure I take the bigger sign. -6 plus -2, they're both negative, so I add those, and I end up with that negative sign still, so -8. So two numbers that are same distance from 0 on a number line, but lie in opposite directions, we can also call them just opposites. So for example, 3 and -3 are the same distance from 0. Think they have the same absolute value. So we call -3 and 3, those are opposites. They have opposite signs. So looking to our second page, if I can find that. Sorry, I got a little lost in there. Looking to our second page, a number and its opposite. So again, think 3, -3. Call those additive inverses. To find the sum of a number and its opposite, we can use our inverse property of addition. And it's a long way of saying something that pretty much happens in every case. For every real number A, so just any number that we're thinking of, and its additive inverse, so again, think the opposite sign of A. If I add the two, so A plus -A, or I could reorder that, -A plus A, whenever I add a number and its opposite, I should end up with 0. So 14 plus -14, I end up with 0. Switch that, -14 plus a +14, I still get 0. Because if I think of it as going 4 to the right, or sorry, 14 to the right, 14 to the left, it's going to end up back at 0. 14 to the left, go 14 to the right, ends up at 0. So I can use opposites to subtract real numbers. To see how, let's look at that number line below, which models 3 minus 5 and 3 plus negative 5. So if I look at that, I should notice that 3 minus 5 and 3 plus a negative 5 are equivalent. So again, if I'm trying to find that on a number line, if I take 3 and I add a negative 5, I can take 3 and move 5 spaces to the left, so I end up at negative 2. I can also think of this as subtracting real numbers. So subtract a real number, I can add its opposite, so a minus b, it's the same thing as doing a plus a negative b. Or, again in some examples, 3 minus 5 is the same thing as 3 plus negative 5, end up with negative 2. Let's look at that as some examples here. 9 minus 9. So 9 minus 9 was 0 because remember I have a number and its additive inverse, so two opposites, a 9 and a negative 9, I get 0. Similar sort of idea, so negative 18, and this was minus negative 13. Something I usually do though when I subtract a negative, and notice there's an example up here also, is that if I subtract a negative number, it's pretty much just like adding its opposite. So again, if I, instead of subtracting a negative 5, I think of it as adding a positive 5. And usually what I do to remind myself, I change both of those minus signs that line up next to each other into pluses. So plus a positive, negative 8 plus 13 would be just 5. So same idea, if I take 4.8 and it was minus a negative 8.7, I can change that to plus a positive, so adding those two I get 13.5. And for what values of a and b does a minus b equal the same thing as b minus a, that's anything where a and b are the same. So like 5 minus 5 is 0, or again if I switch those and they're still the same, 5 minus 5 is still 0. So this next word problem, I did a little bit differently the first time. It was a right way of doing it, but it was kind of confusing to write, so I did it a second time underneath. And let's look at that information. A robot submarine dives 803 feet to the ocean floor. And again, I underlined dives 803 because that information I think is going to be important. It rises 215 feet as the water gets shallower. Then the submarine dives 2,619 feet into a deep crevice. And next, finally, it rises 734 feet to photograph a crack in the wall of that crevice. So to find the location of the crack in relation to sea level, remember sea level would be like 0. I just have to start out at 0 and keep doing each operation. So starting from 0 and diving 803, I have a minus 803. Then I rise 215 feet. Then I dive 2,619 feet more before rising to take that photograph. If I take all those together, negative, I add, I have another subtraction, and I add, I end up with this total, negative 2,473. So in terms of our word problems, we want to make sure we have our units there. That's 2,473 feet below that sea level. And there's a few questions there you want to practice this with as a little check. And again, a quiz in the workbook is going to be that multiple choice, so give that a shot before we come into class. So continuing on with that same idea, last time we're adding, subtracting, this time we're just multiplying, dividing, still with those real numbers. Rules for multiplying real numbers related to properties of real numbers and those definitions of our operations. So these I think are actually a little bit simpler than adding, subtracting, and that's because as long as I have two positive numbers, if I multiply them, it's going to be positive. So for example, like 2 times 2 equals 4, 2 times 3 would be 6, so any two positives make a positive. Think about the product of a positive number and a negative number in terms of groups. So for example, if I do 3 times negative 5, that's like saying that you have 3 groups of negative 5. So if I put together those 3 groups, negative 5 plus another negative 5, I would end up with negative 15. Notice here, we have a different result. Now it's not positive. So our rule there, the product of two real numbers with different signs, it's always going to be negative. And again, different signs means one's positive, one's negative. So positive times a negative, I end up with a negative. Or if I switch that, negative times a positive, negative. As long as I have one of each sign, our result is negative. And we have our model here, so we can see why that is the case. Again, 2 negative 3s becomes negative 6. If I use two numbers of the same sign, and notice it just says same sign, doesn't mean it has to start out both positive, that result's always going to be positive. So if I use 2 times 3, that's going to be 6. Those are both positive. Negative 2 times negative 3 is 6 also because those have the same sign, even though in this case they're both negative. So you can see that in our model. Again, if I have two groups of 3, I have 6. So trying that with some of those examples, I know those were already a little bit visible, but See if you can try and get those before we got to them. Positive times negative ends up negative. Positive, positive, positive. Negative times a positive is a negative. Should be a fraction. Let me roll down there a little bit. So again, when I multiply fractions, I multiply the top. 7 times 3 is 21. 5 times 10 is 50. And I had one negative sign and one positive, so that result is negative. In our last one, we have negative 4 quantity squared. That's like doing two negatives, so same sign means it's positive. So if we notice that negative 4 squared equals 16, like in that last example, I can recall that if a is a square root, that means that a squared is equal to b. So negative 4 is also a square root of 16, just like positive 4 would be. A negative square root, we represent that with that negative radical sign. Every positive real number has a positive and a negative square root, so it should have two. That symbol, and we read that as plus or minus in front of radical, means that you're looking for both of those roots. So let's look at some of those examples. Again, go ahead and give those a shot first of all. If I'm looking for these square roots, square root of 64, again, if I just have a radical sign, it's just going to be 8. Plus or minus square root of 16 means we're looking for both roots, so that's a positive and negative 4. Negative square root of 121 should be negative 11, and again, we're looking for both here. Square root, remember when you have a fraction, do the top and bottom separate, so that's plus or minus 1/6. And you can write it either way. You can write it as 4, negative 4, or just plus or minus 4. So rules for division are pretty much the same as when you're multiplying. So if I have a, b, and c, again, a is not 0 because otherwise the result's just going to be 0. If a times b equals c, then I could also rewrite that as b is the same thing as c divided by a. So a lot of these same rules will follow. Notice I have two negatives. They both have the same sign and it's positive. So when I use division, it's going to be negative, again, if I use a negative and a negative. Let's look at that with some examples. So the quotient of two real numbers with different signs is negative, just like with multiplication. So if I divide negative 20 divided by 5, that result is negative because I have one of each sign. If I use the same sign that's going to be positive, notice I could use either two positives or two negatives. I get the same result. It's going to be positive. And if I divide by 0, we have to be really careful. I can take 0 and divide by a number, and that result is always 0. But you can never take a number and divide by 0, because that's like saying you're trying to group things into groups of 0, which doesn't really make sense. So trying this example, if I make 5 withdrawals of equal amounts, and that part I highlighted because I think that's going to be important, from my bank account, the total amount that I withdraw is going to be $360. And to find the change in my balance every time I make withdrawal, notice that we withdraw 360, so that's losing 360 from your account. Since I make that in 5 equal payments, or 5 withdrawals, I take that negative 360 divided by 5, and a negative divided by a positive should be a negative, because I have different signs. So my result is that I lose $72 from my account every time I make that withdrawal. And if I talk about the inverse property of multiplication, what that's describing is the relationship between a number and its multiplicative inverse. Remember we had additive inverses from earlier. So a multiplicative inverse for every non-zero real number a, the multiplicative inverse 1 over a works so that if I multiply a number and its multiplicative inverse, I should get 1. Compare that to when I use an additive inverse, that would be 0. So the reciprocal of a non-zero number, if I start out with a form a over b, is just flipping that, doing b over a. So the product of a number and its reciprocal is always going to be 1, so the reciprocal is our multiplicative inverse. Can't say that word. Dividing by a fraction is equivalent to multiplying by the reciprocal of that fraction. So usually when you divide with fractions, you're going to use multiplication instead. In our examples, we can try that. So 3/4 divided by the negative 5 over 2. Notice the first one doesn't flip, but the second part, I'm going to flip that from 5 over 2 to 2 over 5, and I multiply, I end up with negative 3 over 10. I'm going to skip over that last one a little bit just because I'm running a little bit short on time, but we can see that it's going to be equivalent because, again, a positive divided by a negative is going to be negative. So you can try that result. That lesson summary is there for you to practice. I'll scroll and look at those answers in a second. And remember to do our workbook questions as far as that little multiple choice quiz. See how you did on that when you come in tomorrow.